Hi guys, in this video we're going to review what exponents are and then talk about exponent rules. So first let's just review what an exponent is. So remember, the exponent is this little number that we call a superscript that may accompany a constant or a variable or a combination of those. And an exponent tells you how many times to multiply the base or the bigger number by itself. So in this case we have 3 to the second power, or 3 squared. And so that tells us that we want to multiply 3 by itself 3 times, which gives us 9. Okay, so if I had, for example, an x squared, it would mean x times x. That's just what an exponent is. So let's look at a few special cases of exponents before we jump into the rules. So first of all, if I have something like 3 to the first power, that can be confusing sometimes, but 3 to the first power, or anything to the first power, is just itself. So it just means that, in this case, I'm multiplying 3 by itself just one time, so it's going to be 3. So x to the first would be x. So sometimes it's helpful when you see things written without the first exponent. Sometimes it's helpful actually to envision that exponent sitting there, that exponent of 1. So that's a special case of when an exponent is 1. Now let's look at what happens when the exponent is 0. This one's kind of tricky, because you think about it and you say, okay, 3 multiplied by itself 0 times, we don't really know necessarily what that is. So I'm going to kind of go through one way to think about this. So I'm actually going to draw a table. So I'm trying to figure out what 3 to the 0 is. I'm just going to write out the next few exponents. If I had 3 to the first power, 3 to the second power. Okay, 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, and 3 to the fourth power is 81. So I can see that as I go this way down my table, I guess it's kind of a table, I'm multiplying by 3 every time. So now I want to know what happens if I were to go backwards up my table. I'm going to get rid of all these arrows, and I'm going to think instead now about going from 81 to 27. There I divide by 3. To go from 27 to 9, I also divide by 3. To go from 9 to 3, I also divide by 3. So I've identified a pattern in my table, which is that to move backwards up my table, I divide by 3. So 3 divided by 3 is 1, which means that 3 to the 0 power is 1. And we'll see later on that if you were to keep going up further in your table, then this pattern would continue. So this pattern of 3 to the 0 equaling 1 holds for anything. So x to the 0, that's 1. 573 to the 0 power, that's 1. Y squared, z to the 7th, x to the 154th, all raised to the 0 power. Anything to the 0 power is just 1. So whenever you see that, just know life's about to get easier, because anything to the 0 power is just 1. So now let's talk about something called the product rule for exponents. So let me write that out. So if you remember, a product means that it's like the answer to a multiplication problem. So let's say we're multiplying something like x cubed times x squared. So I'm multiplying two things and I want to know what the product is if I were to multiply them together. So I'm just going to rewrite x to the third power and x to the second power. I'm going to write it out and break it down as far as I can. So x to the third power is just x times x times x. And then I'm multiplying that by x to the second power, which is x times x. Okay, cool. So I have this expanded expression now. I'm actually going to take away the parentheses. And I can do that because multiplication is commutative, which means it doesn't matter what order I multiply in, I'm going to get the same answer. So I have x times x times x times x times x. Well, I know a simpler way to write that. That's x to the fifth power, right? Now if we look at what our answer was, what our product is compared to what we started with, we see a pattern. If I were to just add these two exponents together, then I would have gotten x to the fifth. And that is the power rule. It says that if I have any number, and it's raised to any power, we'll just call it a, multiplied by the same base, raised to another power, to simplify that, I just have to add those exponents. Pretty sweet, huh? Makes life a lot easier. Okay, now let's look at the quotient rule. So the quotient rule is similar to the product rule. The quotient, if you remember, is the answer to a division problem. So we're going to be dividing here. So let's say I have x cubed over x squared. I'm going to take the same approach as I did when I was working on the product rule, and I am just going to expand these exponents, right, as a bunch of multiplication instead of exponents. So I have x times x times x over x times x. Now I'm going to do some more rearranging. I am going to start grouping these together. I'm going to change this one big fraction into several smaller fractions. Now notice on the last one, I kind of ran out of x's. I had nothing to group it with, so I just put it over 1. Let me actually draw in the groups that I did. So I grouped these two x's together, these two x's together, and then I just said, well, I can multiply by 1 down here. That doesn't change anything. So that's why that x is over 1. Now I can start simplifying. So x over x, well, that's easy. That's just 1. Anything over itself is just 1. So this goes to 1, this goes to 1, and I can just think about this as x. So I have 1 times x, which is x. Okay. Another way to think about this is I'm going to come back to the second step where I have it all expanded. Sorry, these look like subtraction signs, but they are multiplication signs. I can also start canceling things out. So let me get out a different colored pen. I can see, okay, I have an x on the top and the bottom, cancel them out. X on the top and the bottom, cancel them out. So then all that I'm left with is that x on top. Okay. Another way to think about this or to do this is to subtract. So if I go back to the beginning, I had x to the third over x squared. To get the answer to that, I can take whatever exponent's on the top and subtract whatever exponent's on the bottom, and that will give me x to the first power, which is x. Okay. This one's called the quotient rule, and we will do an example of this a little bit later on that's a little more complex. Let's actually look at let's do one different thing with the quotient rule though before we move on. I want to take a look at what it might look like if I had x squared over x cubed. Okay, in this case, if we simplify the way we did in this example down here, the second way, then it would be x times x over x times x times x. I can start canceling things out, and then I'm just left with 1x on the bottom. And that's not really going to work. I need a numerator or the top of my fraction. So it's actually going to be a 1, because remember, you can multiply anything by 1, and it's not going to change it. So it turns into 1 over x. If you simplify it the way we did right here, where we subtracted the exponents, then we get x to the 2 minus 3, which is x to the negative 1. Now here's something interesting. We did it 2 different ways, and we got these 2 answers. And they look pretty different. 1 over x and x to the negative 1 look pretty different. So we are actually going to see that these are the same. In fact, let's do that right now. Let's take a look at why those are the same. I'm going to scroll up. This is going to be kind of confusing. I'll have to annotate these notes later. I want to go back to our table that we made with our 3's. Remember when we were figuring out that, well, let's write down negative exponents. Remember how we figured out that 3 to the 0 power is 1 by kind of working backwards in a table? We're going to do the same thing to figure out what negative exponents are going to look like. So I'm going to write part of my table down here. So 3 squared was 9, 3 to the first power was 3, 3 to the 0 power was 1. Now let's say I have 3 to the negative 1 power. Well, remember that my pattern in my table is divide by 3 over here. So I'm going to do 1, and I'm going to divide it by 3. And that is 1/3. Okay, so I want to do 3 to the negative 2 power. Well, I better divide by negative 3 again. 1/3 divided by 3 is 1/9. 3 to the negative third is going to be, I have to divide by 3 again. Ooh, that's kind of a crooked arrow. 1 over 27. Okay. So here's some important patterns to notice here. Let me get my highlighter out so I can highlight these. Notice how like 3 to the negative first power and 3 to the first power are related to each other. And 3 to the negative 2 power and 3 to the second power are also related to each other. So the denominator of our fraction is the same as the answer down here, right? So I'm going to rewrite this in a little bit different way. So this is getting kind of messy. So 3 to the negative second power we can think of as 1 over 3 squared, because 3 squared is 9, right? And then 3 to the negative first power we can think of as 1 over 3 to the first power, because 3 to the first power is 3. So this tells us that with a negative exponent, it basically means that we can turn it into a fraction. Okay, so if I have, let's kind of write the general rule down here. If I have x to the negative a, and a can be any number, that's the same as 1 over x to the a. So by bringing this whole thing to the bottom of a fraction, then I'm able to get rid of that negative exponent. And the reason that's important is because we really just don't like negative exponents. They're just not great. So we generally prefer to have our negative exponents written as fractions like we have right here, 1 over x to the a. So let's go back down to the example that I was doing a while ago. And now we can see that when we are simplifying x squared, let me get my highlighter out again so I can point. When we were simplifying x squared over x cubed, and I got 1 over x and x to the negative first, that was okay because those two expressions are equivalent. These two are equal to each other. Negative exponents are really important. This rule is super important to remember, and you're going to keep seeing it a lot. So we got to remember that one. Okay, let's look at 2 more rules that we need to deal with. Hopefully we can get through all of them. Okay, first is the power rule. So the power rule means that I'm taking something that's an exponent, like x squared, and I'm going to raise it to another exponent. So I've got like double exponents going on, which can be kind of confusing. So I'm going to rewrite this as, I know that I'm taking x squared and I'm multiplying it by itself 3 times. So I have x squared times x squared times x squared, right? Now I can use my fancy product rule to say x squared times x squared times x squared is the same as x raised to the 2 plus 2 plus 2 power, which is the same as x to the 6th power. Now we can look at the relationship between the exponents we started with and x to this x squared all raised to the 3rd power and the final one. We notice that those exponents are multiplied together. So the 2 and the 3, the exponents we started with, are multiplied together. So let's write a general rule for that. If I have x raised to the a power, a can be any number, and then I raise that whole thing to the b power, then I get x to the a b, and those two are multiplied together. That's a super slick rule. It's going to become very, very useful. I'm going to have to make another video for the last 2 rules. So I'll make another video that has the last 2 rules in it and has a few more complicated examples. So this is just our basic rules of exponents, and then see the next video to get some more complex examples as well as some 2 additional rules.